Just a second, it'll start. Okay, welcome everyone to the June 2022 Houston Job User Group meeting. Thank you all so much for joining. Whether you're joining us live or watching via YouTube, thank you so much for being here. Tonight we have Frank Greco, who is the leader of the New York Java SIG. One of two, if I remember right, Frank, the Java user groups in the New York area. Thank you to the meeting sponsors, Improving. They're my employer, full disclosure, but they're a fantastic employer. They're consistently voted one of the best places to work in Houston and in many of the, if not all of the markets where they operate. We're looking to hire Java developers as well. Feel free to reach out to me at jim.bethancourt@improving.com. Oh goodness, what else? Thank you also to our door prize sponsors. We have free licenses. I'll post the link in just a minute in the chat. We have free licenses of IntelliJ Ultimate, Sonar Graph from hellotomorrow.com, Structure 101 IDE plugin license from Headway Software, Agile, a one-year subscription to Agile Learner from Venkat Subramaniam. He is a fantastic speaker. I would highly encourage you to seek out his talks, and also a voucher from Webucator. That's all I can think of as far as door prize sponsors. Again, our Improving our hosting sponsor. Next month we have a really neat presenter from I forget where he's from, but flying into Houston, and they're making a really neat tool. And it will actually automate the refactoring of your Java code bases. Modern.io, moderne.io, if you want to check it out. I'll post it here in the chat as well, if you want to take a look. Again, they'll be here in person, presenting at the Improving offices, and I'm very, very excited. Again, what they do is they'll take, it looks like from what I gather, they will take and they will parse your code base and figure out where things can be improved using such as if you want to migrate from Java 8 to Java 11 or from Spring Boot 1 to Spring Boot 2, and also for other frameworks as well. Pretty neat stuff. So that's again all I can think of right now. Hope to see y'all there next month in person if possible. It'll also be a hybrid event, so I'll be recording it and broadcasting out as well. And so, Frank, please tell us all about JSR381 and computer vision in Java. I'm very, very excited to hear more about this.
Great. Thanks, Jim. Thank you, Houston Jug. And since this is recording, hello, people of the future. Nice to meet you. So this talk is about JSR381, but it's more about machine learning, and it's bigger than JSR381. So what I want to do is expend the first half of this presentation talking about machine learning and why software developers should not ignore machine learning. And I'll talk why I get interested in machine learning and a little bit of my background. And then the second half will just show code. I have two really cool demos showing off the API, the JSR381. As we affectionately call it, VisRec for visual recognition. So VisRec API, and tell you how it's implemented. So patterns, predictions, and prescriptions. Why all of you should not ignore machine learning. So that's me. When you see the video, you can connect with me on LinkedIn. Feel free. Again, the first half is more or less a little. I want to take a step back and talk to you about machine learning. I know you've heard about that term, and I want to kind of explain that to you and tell you why I think it's a huge trend. And then we'll talk about, we'll show some code and some really cool demos. So we all have read about machine learning in the regular press, you know, in our own computer press, and also the regular everyday press. And it has a huge, in my opinion, it's a huge impact on everything. I mean, to me, it's like the invention of the electricity or the printing press, or even computers. At the picture on the left there is, I should say, the invention of the calculating machine. The computers, actually, the women in the pictures were called computers, which is a kind of a interesting story. They were called the computers, not the machine. But
like was it the operating system was the operators of the were the operators of the system.
That's right. So it's to me, and then we have a picture of a neural network on the right hand side, machine learning. It has a huge impact. And I started about 3-4 years ago working just because I was fascinated. You know, like when you're learning stuff and you look in your career, so what should I learn next? And you're like a surfer in the water, right? You're waiting for what are the big waves? I want to ride a big wave going in, right? So you see all these little waves come by. And that's not that interesting. That's interesting, but that's just, you know, not that interesting. That's just, and then I see machine learning. It's like, wow, this is like Java. You know, when I first was introduced to Java, I just thought it was just another language, and I didn't realize it was like an ecosystem in a community and a set of languages and tools, and it was much more. It was much more than just a language. So when I looked at machine learning, this is much more than just like a framework or an API. So in my opinion, this is machine learning is huge. It's an inflection point just for not only for us as people in the computer industry, but it's certainly important for enterprises and businesses. It's an inflection point for countries, humanity, and civilization, in my opinion. And I'm not kidding. This is like, you know, I had my epiphany at 3 o'clock in the morning doing coding, and I realized the impact that machine learning has on civilization. And you get this cold chill down my back. So this is huge. So here's how I found out. So the crux of machine learning is all about patterns. It's all about patterns. And so let me tell you a little story. So when I was in grad school, I mean, this is going back a few years ago. So we didn't have laptops to work on. We had to go to the computer lab. And you know, I used to hang out in a computer lab till like all hours of the morning, you know, 2 o'clock, 3 o'clock in the morning. And I used to sit next to this big disk drive. And, you know, it's not like disk drives you have in your laptop, which are either solid state, nice and quiet. Though this one was noisy and it was big. So I sat next to it, primarily because it put off heat. And I like the heat. So I sat next to it and made all kinds of noises. And, you know, while I'm programming away, I see this dude, he goes into the back of the room and he starts up, you know, his programs. And I noticed that the disk drive makes a certain noise, right? So it made a different noise than my programs when I was running it. You know, it was just accessing data on different parts of the different platters, or the old-fashioned platter Winchester mechanism. So whenever he would come into the room, this dude would go in the back, and I would look in the back, said, there he is in the back of the room, and I would hear the machine make that same noise. Then one day, he walks into the lab. Well, actually, one day I didn't notice he walked into the lab, but I was kind of concentrating on something, and I heard the machine make that same noise. And I sort of joked to myself, I bet that guy's in the back of the room. And I turned around, and sure enough, he was sitting there and he was running his program. So I thought to myself, I was kind of like laughing at myself. You know, actually, I was able to predict something just by listening to his sound. I was able to predict that he was running his program. So I was laughing to myself. But I said, like, you know, I was kind of like predicting that this guy was in the back of the room. So I thought that was interesting, right? So I held that thought for quite a while. And some of you out there, and certainly the people in the New York Java SIG, know that I'm also a musician. And I've been a musician for probably just as long as I've been a computer person. So if you are a musician, and many of you are musicians, right? If you're a guitar player like myself, and I told you that we're gonna jam on a blues progression, like the B.B. King here on the left, I'm gonna say it's a 1-4-5 in the key of C. And if you have any knowledge of blues, you know exactly what their chord progression is. You know that pattern, and you can collaborate with me. And if you're a jazz guitarist, like the one on the right, and I said it's a 2-5-1 in the key of A, and your jazz guitars, you know exactly what the chords are. I don't have to tell you what the chords are. I said it's 2, 5, 1, and A. And you know how to play against that. You know the pattern. So being interested in patterns, I mean, my graduate project was looking at melodies from a composer and then generating original melodies in that style. So that was my grad project. And it involved all kinds of building probability trees and fractal probabilities, all kinds of cool stuff. And just for a lark, I mean, since there wasn't anything visual, I mean, just a hint, when you're developing a demo for somebody important, like my supervisor, my grads, create something visual, right? So you need some eye candy. So I said, well, it's going to be fun. I'll just be able to draw out the staff, the musical staff, and then I'll let the user able to transpose to any key just for fun. It probably took me like a couple of days to implement that. And it was just, for fun. And the funniest thing, like during my presentation to the other professors and also other students, everybody was interested in how we created the graphics program, and not too many people are interested in the probability. So it goes to show that eye candy is very important. But the thing about this, the point about this is that it was about musical patterns. There's that word again, patterns. So a few years, fast forward a few years, I worked for the New York Stock Exchange, and I worked in the surveillance department. And I just got lucky, and I worked in a group of AI, really, really strong AI developers and researchers. And I was the junior person there. I was the UI person. I was working on the front end to all this stuff. But I learned, and I became close friends with a lot of these people. They were all focused on finding patterns on illegal trading. And this is, back in the late 80s, early 90s. So we were looking for trading patterns. So we had prologue programs looking for patterns on when things would happen. It's like, well, why did that person do this when this was happening, that was happening? So we were looking for patterns. So that kept that in my mind. So there's patterns again. And then later on in my career, I worked for Lehman Brothers. I mean, you might remember that company. I was there until the last week before they blew up in 2008. I could tell you more, but I think I'll say that for another time. But I worked in fixed income research, and we were working on portfolios. And we told people that we had this portfolio attribution system that we can tell you why your portfolio went up or down, which is basically a stretch of the truth because we didn't know why things went up or down. We can tell you that it went up because you have a large position in this one thing, and that thing went up or down. And that's the reason why your portfolio lost money or made money, is because that thing lost money or made money. Well, that's not a good answer. So why did that thing go up or down? We didn't know. So we tried to look for, we found a correlation engine. I mean, that's just mathematics, just arithmetic. But we tried to find why things happen, a causation engine, but that was hard. That was really, really hard to look at that. So we gave up. But
there's multiple numbers of factors too. So I mean,
yes, exactly.
It could be technical, or it could be.
It's not easy.
It could be domain specific. Yeah,
yes, exactly. But there's that word again, patterns. So I thought, it's like, wow, all this stuff it's all about patterns, right? And everything in my career is everything about patterns. So then I kind of, picked my head up from looking at, code and algorithms and stuff. And I looked around and I said, like, well, there's music. And I had an interest in astronomy and astrophysics, and I know there's a law in astronomy called Chandrasekhar's limit, when it's life of a star, and when a star starts to pulsate, and then it gets too chaotic and it blows up, and we get it just a nova or supernova. So when the chaos index, and this happens in business, and things blow up, right? And we can look at technologies. Why did a new technology come along? Well, things are too chaotic and they blew up and something new came along. And I said, wow, that's a pattern. There's a pattern in astronomy. There's a pattern in music. The bears use, they use patterns to find food. They know where the river to fish. There's the problem-solving patterns. There's fern, in nature. There's sports patterns. Like, so you're European football, you know the patterns of your opponent and you know how to play your opponent. In American football is where we don't use our feet, but that's another thread. You know the patterns of your opponent. So there's patterns. And we know as Java developers and as developers in general, and being a Unix person, this is near and dear to my heart, is regular expressions. So here's regular expressions. So regular expressions, I mean, many of you don't know this, but regular expressions were invented in 1947. So when artificial neural networks were created, and that was 1946, actually same time as when the subroutine was invented. So we have neural networks basically mimicking human intelligence. Stephen, if I remember it, Klein invented regular expressions because he was interested in AI. And he wanted to test artificial neural networks, but with text. Right? He couldn't do it with images like we can do now, but he could do it with text. So we created regular expressions to test patterns. There's our word again, patterns in text. And of course, we know that why are regular expressions popular? Well, a young developer, a young researcher at Bell Labs, who was also interested in AI, said, no, the regular expressions are kind of cool. I'm going to add them to my editor that I'm working on. I'm going to create this new operating system in this editor. Let me throw them into this little editor. And let me tell my colleagues. Well, that researcher was Ken Thompson, right? And he put it into the ED editor in Unix. And he told his colleagues who created grep and they created awk and made regular expressions very popular. So regular expressions come from an AI background, which is interesting. But the thing is that regular expressions are based on patterns in text. And we know about patterns. If you've been around, been developing for a number of years, you know that there's this famous book on using design patterns, common idioms or in the language. Well, this famous book, was based upon a talk at a conference, at an UPSLA conference, so Object-Oriented Programming System Language Architecture, I think. But it was based upon a talk by Kent Beck and Ward Cunningham on using pattern language for OOP. So that was 1987, which influenced this book in 95. But that talk was influenced by this book, right? And it also influenced Ward Cunningham, who worked in that talk. This book is about building construction. So this influenced a talk in UPSLA, which influenced the Gang of Four book. And this also influenced the development of Agile. So we see a pattern. The pattern is influence a pattern, which is influencing a pattern. And of course, construction patterns themselves are not new. So they come from building construction over many years. So the next time you use your facade pattern or decorator pattern, it comes from somebody building, some an old building in a mountain or something, or a hut. But it's based on construction patterns. So not only software patterns are based on construction patterns, and then there's patterns for problem solving, which is used for businesses. Then there's enterprise patterns and systems of patterns. Then even further, there's fishing patterns. There's clothing, human growth patterns. There's cultural patterns. There's bloodstain patterns. So this to me struck me. Like there's patterns everywhere. As a matter of fact, so here's another weird pattern. So in France, there's the train system in France, right? It connects all the cities together, and many engineers worked on that. Connecting the most efficient way to connect all the cities in France. Somebody took the map of France, put slime mold, and put slime mold's food, which I think is oatmeal, that's their favorite food, put it in locations where cities would be represented, and then using time-lapse photography, followed this. So the slime mold essentially duplicated the pattern of the train system in France, and they've done
In
this
less
for
than
other.
a week.
And it's like mind blowing. It's like, wait a minute, like human intelligence created the train system, and then here's slime molds, which we didn't think was intelligent, using a pattern to solve a problem that we use. So all these things were fascinating to me. It's like it just it really struck me. So patterns are everywhere. So now let's take a step back and talk about coding. So we have traditional computing that we've been doing for many decades, right? And most of the things we do for our companies are well defined, right? Many of the algorithms are well defined, pretty straightforward. We can calculate sports and bowling averages, or calculate money from turnstiles, count GitHub repos in whatever language. So these are pretty straightforward things. So traditional software, think of it as like it's like an expert system, right? It's like there's if-thens, you go that way, you go this way, you go this way, you go that way. There might be a loop someplace, but it's essentially a set of rules, right? That's traditional software. But most things, well, some algorithms are not well defined. So for example, let's look at visual recognition. So we have, here's two pictures. There's a picture of a Chihuahua on the left and a Muffin on the right. Now, when I gave this talk in Nigeria, and I said, this is a Chihuahua, this is a Muffin, and I saw all these like blank stares, and it wasn't until my colleague said, like, they don't know what a Chihuahua is and they don't know what a Muffin is. I said, well, what should I say? And he goes, just say puppy and just say cupcake. So there's a puppy on the left and a cupcake on the right. So if your job is to identify a Chihuahua or a Muffin and come up with rules, okay, you'd say, okay, the Chihuahua has it seems like 3 dark areas. Okay, so if there's 3 dark areas, there's looks like whiskers there. There's a mouth there. There's a little white here. There's a little brown here. It looks like 2 ears. Okay, so that may be a set of rules for that. And then for the blueberry muffin over here, I said, well, maybe that's not so a dark spot, but it's not as well defined. There's a dark brown spot there. There's this crack here. There's this like a wrapper here. So you come up with rules. Maybe you have several dozen rules to determine whether something is a Chihuahua or a Muffin. And you said, like, okay, I have my rules. I'm ready to go. And your manager says, you ready to go into production? And of course, developers like, yeah, I'm ready. Let's go. And it's like, okay, here's thousands and thousands of images are coming at you. And you kind of look at it, well, wait a minute. So if the images is rotated, or maybe there's more than 2 black dots there, is this a blueberry? Is that a blueberry muffin? Is that? So you start adding more rules, right? You start adding more rules. So instead of several dozen, maybe you have 100, maybe you have 1,000, maybe you have several thousand rules, maybe even more. So because you have images that are maybe rotated upside down, there's one with multiple dogs in the picture. Here's multiple dogs reversed. So you start increasing the number of rules. Then what happens when you start increasing the number of rules? Well, what I call the chaos index goes up. This is what I tell a lot of my students. When it's like looking when you first learn programming, you look at an if statement and you say if this and that or this and that, and all of a sudden it's like, I don't understand what's happening. That means the chaos index is too high. You can't understand it. If you can't understand something in 5 seconds, it's too complicated, right? So you got to break it down to subproblems. So here the chaos index is high if you have like thousands and thousands of rules. That's not good, right? And we know when the chaos index is high, that means the chance of bugs is high, and that's something that, of course, we all want to avoid. So this isn't working out too well. But this type of problem applies a lot of different places. It applies when there's a large number of parameters and tons of data. So where's that? Seems like everywhere, right? From cybersecurity to trading, medical to healthcare, language translation, call centers, all these big problems are not straightforward to solve with simple algorithms, right? So, which brings us to machine learning. So machine learning, so the core of machine learning is recognizing patterns in data. Okay, so you're recognizing patterns, and then you make predictions against that data, right? So you recognize patterns and you make predictions. It's like a regex or like a regular expression, right? But if you're talking to your boss, you say something more like this. I mean, you recognize patterns so you can predict the future, right? But that's not enough. I mean, why are businesses interested in machine learning? It's not to predict the future. Okay, you want to recognize patterns. You want to be able to predict to a certain degree, right? Likely future behavior. But the most important thing is that now that you think you know the future, what steps do you take to maximize ethical business benefit? Right. That's the third, and that's probably the most important. You recognize patterns, you can predict things, but then what do you do to maximize business benefits? And I should stress ethical business benefit. So there was a researcher that said all this back in 1948. So Norbert Wiener, right, at MIT, he said this famous quote that people have forgotten. Maybe it's not so famous then. One of the most interesting aspects of the world is that it can be considered to be made of patterns. I mean, I would expand that to be the universe. One of the most interesting aspects of the universe is that it can be considered to be made up of a collection of patterns. So this is the 40s. This is the 40s. So this was AI before AI. And this is different than the computing we've been doing for decades, right? So in the program we've been doing for a long time is that we have data, or is always data, right? And then we have a model, a mental model, right? So we have a model in our heads, like we have algorithms, we have data structures, we have an idea how to solve the problem. We give that to the machine gives us a result. Okay, that's basically what we've been doing for decades. But with machine learning, it's a little different. It's sort of inverted. That we have data. Matter of fact, we have lots of data now because we're data collectors. Right? I mean, we have tons of data, and we know what the result is. Basically, that's saying that in my data, look for patterns, and if you see this pattern, you can predict the future. So if you see new data, and that falls into that pattern, this is the result that you should get. Right? So if you give machine data and you say, like, if you see similar data, you should get a similar result, right? Whether it's sports or in finance or in astronomy or in mortgages or whatever it is. And you ask the machine, how did you get that? How did you get that result? Give me the model that you created. So if you notice, it's a little different from what we do as regular programmers, where we know in our head how we're going to solve with data structures and if statements and loops. Whereas we ask the machine, how did you figure that out? How did you know that couple that's asking for a mortgage they were approved? How did you know that? Give me that model. So it's a little different from traditional software. So why did I work a little with my colleague Zoran Ševarc from the University of Serbia on JSR381, okay, as we affectionately call it, VisRec, for visual recognition? Why do we do that? Okay, so I was interested in machine learning, right, back 3-4 years ago, and this is what I got when I asked people, how do I do machine learning? How do you get started? Well, and students are told this now. You can write your machine learning app in any language you want, as long as it's Python, right? This is apologies to Henry Ford for stealing this. You can have any color car you want as long as it's black, which is his famous quote. So I'm a Java developer. What are you talking about? I mean, it's machine learning is not just tied to Python. Why is it always Python, right? And it's not just me saying hey, but there's 10 million heys out there. So there's 10 million Java developers saying, what are you talking about? It's like you're telling me I have to learn Python to do ML. So here's a big, huge civilization changing trend, and you're telling me there's only one language to do that. Well, so this is, we're one of these 10 million, and Zoran is one of the other 10 million. So we both said the same thing. Hey, so we said, like, Java needs to be a first-class citizen for ML. So we don't want what we call JavaScript doomsday scenario. So what I mean by that, so the web, and I was working on hypertext back in the late 80s too, before, right when TVL, as we call them, Tim Berners-Lee invented the web. huge trend. There's only one language to express your creativity on the web. It's JavaScript. That, to me, that's like you're a bunch of musicians and I gave you a clarinet and I said, I want you all to express your musical thoughts just using a clarinet.
That was built in 10 days, no less.
Right, exactly.
It's carved, yeah. So it's, if I remember right, JavaScript was, he developed Brendan and I came up with it, put it together in 10 days for the very first release that he'd cut. I remember right.
Look, that's possible. So JavaScript is a made up. So its real name was LiveScript.
Okay.
So Netscape had LiveScript, and back in 80 or is it 96? 96. In 96, since I know the person that she talked to Netscape and she was involved with Java at Sun, and they said, like, let's work together, partner. And maybe if you change LiveScript to JavaScript, and because Java is getting popular,
catch out of the cachet, yeah.
Right. So joined together, we wanted both to take off. So actually, JavaScript's first name was LiveScript, and JavaScript was just named to leverage the popularity of Java back then, which is so. That's the history. And I was back there, so I know the people involved in that, the marketing people. Yet another marketing decision. Python is a great language. I mean, I love Python. It's a great language, but there, like I said, if you use that clarinet metaphor, there should be other language to express your creativity, right? And of course, we love Java, right? It's a huge ecosystem, right? There's millions and millions of developers, and there are some ML APIs out there, but they're typically like C language libraries that have like a very rough Java wrapper, so they're not really Java friendly. They sort of look like Java, but they're not really Java friendly.
And then you have JNI wrappers or stuff like that memory pinning issues, stuff like that you could run into. Just, it can be a bit of a headache, I imagine. I've never worked with them directly myself, but I've heard enough several stories along those lines. It can be a headache.
Exactly right. And at the same time, I guess this is back in 2018, I ran a conference with this gentleman, Humphrey Scheel, a really nice guy. And he was like me, like a longtime Java developer. And he was told he had to work on a machine learning application. And he said he was forced to learn Python. And he said, like, for deployment, it's just a headache. I mean, I have this picture of this restaurant that he was a keynote speaker. He's also a marathon runner, so he had to he had to cancel his keynote for the first day because he ran the marathon the day before, and he said, I can't move my legs. So I said, okay, so I'll move you to the next day. So make sure you're in Rome, Italy by this morning, or else I'm going to be doing card tricks to the audience. So he missed the speaker dinner, but the next day, this is how this serendipity works. That it was just, I took him to dinner since he traveled to speak, and it was just the two of us in this little cafe, and we sat there for 3 hours talking about what Java needs for ML. And he put his thoughts and our thoughts in that article. So there's a little link down the bottom. It's a really cool article. So we need to promote Java for ML, right? And so we looked around, so we didn't see anything that was useful. So my colleague Zoran, who was also giving talks on ML in Java, he had the same thought. Said, like, there isn't anything good. So we know the famous computer scientist Alan Kay, who gave us practically mostly everything that we use today. The best way to predict the future is to invent it yourself. So that's what we did. So we wanted to make ML more approachable for Java developers. So we went and talked to all these companies. We talked to Brian Getz, of course, and Mr. Java language. We talked to Twitter, Google, Azul, Amazon, everybody. And we said, are you interested in the Java API to machine learning? They all said, yes, especially for deployment. For prototyping, there's nothing wrong with Python for prototyping. We said, but for deployment, we wanted Java. So I said, wow, all these big companies want this. So what we did is that instead of tackling all of machine learning, right, it's just one thing that you learn in management, like don't boil the ocean, right? To take a problem that there's a deliverable, right? So we said, like, let's do visual recognition, because first of all, it'll be fun, right? It'll be fun for developers to see how you can do machine learning for VisRec, for visual recognition in Java. So Zoran and myself, and we have a colleague, Kevin, who is very valuable. He was a fantastic architect and coder from Open Value. We worked together with a bunch of friends, and some of these names I'm sure are familiar to all of you, that they were all helping us out, advising and contributing to the JSR. And even Amazon was so interested that they actually implemented our API. Right, so JSRs are APIs, right? They're standard APIs. So they implemented our API.
As a reference API, or as a secondary API to show you, yes, somebody else can do it too?
Well, they were the second one. We did it first.
Okay, wow, nice.
Yeah, the first one we did it was with DeepNets at the open source ML library, and that was our reference implementation. And then Amazon, which we didn't know until they were finished with it. Frank Liu from Amazon, he contacted us and said, "Oh, I just implemented your API using our DJL." It's like, wow. So they have this really cool article in InfoQ on how I did that. So that was pretty nice. So JSR381, again, it's, as we affectionately call it, VisRec, it's a Java-friendly standard, right? So it's Java developers will feel comfortable with it. It's not a set of C libraries that you have to understand how C works and pointers, things like that. It's Java-friendly. And not only for visual recognition, but it has a generic ML API. But we're stressing VisRec just for developers to learn about that. So it's definitely Java-centric. Being Java developers, we did not want the Java wrapper on a C library. We want pure Java. So here's the problems that we saw with. There's probably about 10 libraries out there for ML, maybe 15. Of course, they're all different APIs, right? So we know the good things for standard APIs. They had different algorithms. They're too complicated. You have to be a data scientist. And people said, like, should I learn data scientist, the science to be an ML developer? I took statistics, in university, and I know I've taught thousands of students. I know a lot of students are never going to learn data science. They're just not geared that way. It's just like how a lot of developers are not geared towards UIs. They're just not geared. They're mentally not geared that way. And people think like you can do everything. You're a developer. You can understand everything. That's not true. People's brains are wired differently, right? So most developers will not learn data science, and most people will not learn data science. Only a small group of people have that capability. And on the contrary, since I've worked with quants on Wall Street, they are not good programmers. So they are not good programmers. They're really nice people, super, super, super smart people. But I used to sit near them, and they would walk over to my desk and say, "Frank, how do you do this program? How do you do that? How do you do that?" And so I would be quite impressed with their stat background and their worldly knowledge and how geopolitics works and things like that. But programming skills, I'm not sure.
It might be no insult to math majors, but yeah, I'd hear stories about, "Oh, I'm a math major. I can write software."
Yeah, then it comes to deployment. It's like, deployment is a little different than just writing a prototype. So our goals were to make it familiar to Java developers and make it easy to implement also. So we're hoping somebody, now that the TensorFlow Java API is I should say better. I mean, open source community has done a really good deed in working on the Java API of TensorFlow. So we're hoping somebody will implement our API using TensorFlow. So here's a rough idea on the architecture. So what you as a Java developer, you'll be working with this like this orange box here. It's a public API. And how it works internally, we have a VisRec set of code here with the image abstraction, because there's different, like Android has a different notion of an image versus pure Java, and other libraries down here at the engine level, at the low level, have different ideas what an image is. So we have an abstraction for that. And then we use Java's SPI, the service provider interface, to talk to whether it's Deep Nets implementation or it's the Amazon implementation. We're hoping somebody will do the TensorFlow implementation or whatever engine down here. So we built the API, and that's what you would be using. So let me see if I can show. Actually, let me talk about the code, for example. Before I show that code, so here's a rough idea when you build when you're on an ML project. Here's a really 30,000 foot level view of what that is. There's like 3 basic boxes. I mean, there's data prep, right? You make sure that you have clean data, unbiased data, solid data. Actually, this is probably the hardest part of everything, is getting the data clean, right? Then the middle part is that you build a model, right? You select what algorithm you want to use. The neural network, there's many dozens of neural network algorithms, so you have to pick which one you want, check this, mess around with parameters, experiment, things like that, and you're constantly testing the model, tuning the model, and you kind of go in this little loop until you're happy with the model, and then you put it into production where you're predicting the future. Right, that's the normal thing. Actually, if this was drawn to scale, this data prep would be a box the size of my wall, the size of my house. This is the hard part. That's why data engineering is a really good career move for a lot of people. This is really, really important. But we're going to kind of, for our demo, we're just going to do data prep, train a model, and predict just for fun. Okay, so since we were talking about Chihuahuas, I figured I took there's a dog data set from Stanford, and there's a link down there. And I took some pictures of Chihuahuas. They have a whole folder, directory of just Chihuahuas. So there was that folder only had 872 images. So keep that in mind. It was only 872 images, images like this. And here's our API. Here's one of our API. Here's the builder API, where we're going to create a model, right? So there's 2 programs here. We're going to create a model, save it to a file, and then we're going to get a second program that's going to read that model and then predict the future. So let's create the model first. So we have this builder API. It says, okay, I have buffered images. Here's a height and width of an image. There's a labels file. What a labels file is what are you trying to classify? Right? It's just sort of like in Java when you're creating classes. You want to classify, these are Chihuahuas, these are not Chihuahuas, right? These are other dogs, or these are, you're coming up with classes. So labels is like dogs would be a label, right? And if you only have one label, there's only one entry in that file. It's just dogs. If you have multiple, there's multiple lines, right? If you have 3 classes you're trying to define, there's 3 entries in that file. Then there's the training file, which is where are the images, right? I'll show a working example of this particular demo. There's a network architecture. I'll come back in a second. Then the export model. In other words, create the model file and save it. So and give me the name of it. Maximum error. So what type of error do you want? Do you want 99% accuracy? Do you want 50% accuracy? Do you want 75% accuracy? That's error. Since machine learning is an iterative process, how many iterations? In machine learning terms, it's called epochs. Just how many iterations. And I'll skip learning for now. So you have this builder, and you create the model file, right? And then you give it new images. So these are new images. These are not part of the original data set. Here, 1, 2, 3, and I have a mushroom. Let's see what happens. Okay. So then I have a second program. So once my classifier runs, right? Once my first program, this guy here, once this program runs, and of course, when you're playing around with this, if it's suggested that you use, don't look for like 99% error right away. Do it so just get it to work first. Get it. Say I only want 75% accuracy, just so it can work rather quickly. If you want very high accuracy, it could take a while, especially if you don't have a GPU. So my Mac does not have, well, I should say the software does not use the GPU on my Mac. So when I ran the first program, I had a nice long dinner. So it was like 2.5 hours while it was running. And then the second program runs really quickly because now you have the model file. So here are new images. And I'm running, here's basically the second program, is that it's the same type of image. Here's the with height, get the model file, and then now make your predictions. So I have new images here, 1, 2, the mushroom, and 3. So, and here's what I get for output. So for the first dog, I got 88% accuracy. That's definitely a Chihuahua. 88.7%. Yes, that's definitely a Chihuahua. What's interesting here is there's a mushroom. It says it's 66% sure it was a Chihuahua, which is kind of weird, right? And then the third one was 87. So here's how it looks. This one's 88.5. This is 88.7, 87.8. But it also had mushrooms were 66%, which that accuracy is certainly not good, right? So when I wrote this program, notice what I said before. There's only, let's see if I have it back here, 872 images, right in the bottom left. That's not enough images. So you need to have a lot of images. And some data scientists, and Andrew Ng, one of the godfathers of ML in today's world, he said you really need probably about 10,000 images to be accurate. So I didn't have enough images, so that's why kind of like, well, maybe that possibly could be a Chihuahua. So that's, yeah. Let me show the. So here's good old IntelliJ, and I'll increase the font here. So this is the, oops, that's not the right, this guy. This is the first program. The first program is basically going to create the model file. And this is the thing that takes a long time to run. So that's why the first time you get to run, just lower the error rate, not the max error. Just make sure it works with your data set, the images, the labels. As long as it's working, you can see it kind of fly by every few seconds. It does an iteration. When you want to do it in production, then let it go full and just go take a walk or something like that. It'll come back in a few hours. Now, this is the reason why you need GPUs and you need hardware assist, like running it in the cloud with some GPU assistance, then it runs real quickly. That's why hardware assist is very important. So the model file. So what did I use for model file? So my model file. Okay, so actually it's over here. I've yet to figure out how IntelliJ can increase the font size of this pane, but I think I could do it through the Mac. So this program ran, and I put the file into model.dnet. So this is the name of my model file. There's a little backup just in case. Every presenter knows you need a backup just in case something happens, right? So here's my model file. So this program creates that model file. Here's what I had: dogs and mushrooms, right? So and there's a data set. Like here's a label, here's a path of a dog image, and I said, well, that's an alpha dog, what I call an alpha dog. Here's another image, that's an alpha dog, and other images. So this is, I had a little bash program that created this. It's just like, where are the images and what is it? Is it a dog or a mushroom, or is it something else? So that's what this mapping file does, my data set does. And then finally, once I have the model, this small program just runs it. So actually, this is identify app. So I'm here, Chihuahua 1, 2, mushroom, and 3. So let's say I gotta run identify app. Let's make this bigger for you. Yeah, Gradle wasn't running. Okay, so here, oops. But here's the values that I got and that I showed you. And let's see. And I just printed out how much time it took. So that's pretty fast for my Mac. So this is an example of just creating a model for dogs and checking against mushrooms. But it did show me when I created this, like I really need more images to have a high degree of accuracy. So that's that. That's that demo. Let me go back to here, and let me go to demo number 2 since I'm okay. I got a few minutes. So there's this really funny episode of Silicon Valley, which was I consider it to be a documentary of Valley companies. Since I've worked for a Valley company, I consider this not to be a comedy show, but to be a documentary. But there's a very funny episode about machine learning, where there was an app that looked at an image, said whether it was a hot dog or not a hot dog. So it's a very funny episode. I suggest you watch it. It's really, really funny. So we wanted to build a similar app that detected whether something was a hot dog or not. So actually, Zoran wrote this demo. Right, here's a Maven dependency. Just 2 main things. There's the API, and then there's the reference implementation. In other words, our API, and then the implementation, whether it's the Amazon implementation or a DNet's implementation. Hopefully, future we'll have a TensorFlow one. And here's the builder, and here's what Zoran was doing. He had 128 by 128 images, right? And here's all his data, and it created, where did he put his model? Oh, here. So he put his model into hotdog.dnet. So that's where he's saving his model, right? And while he ran the training program, remember there's 2 programs. One creates the model, one that uses the model. So his first program, like every epoch, every iteration took about 3.5 to 4 seconds, right? And the error rate, notice the error rate is getting better and better as more you go, and the accuracy should be getting better. So you just basically can watch it, you go, and you can say, like, you can do this 100 iterations or 1,000 iterations. Depends on what you want for accuracy, right? This is up to you. What training area do I want, and how accurate do I want it to be? And then once you're done, you read the model, you give it a new image and say, like, okay, classify that image. Is that a hot dog or not a hot dog? And the data that you get back, it's a probability. I mean, this is right. It's different. It's the old-fashioned programming. You get a result, a hard result. With ML, you get a probability. It's like the weather, right? Like the weather person says, like, it's going to be sunny tomorrow or it's going to be stormy tomorrow. That's 85% accuracy, right? And 2 days, 3 days from now, it gets even worse and worse. I think at 3 or 4 days, it's like 50-50, right? So so we're looking at probabilities here, right? And here's some details, but you know what? Let's just probably useful just to show the code instead of looking at the details. That's our mushroom. That guy. Okay. So let's see, blow this up. Right, here's I was just showing you that here are the image sizes, the files, and here's the second program that reads. So it reads the model file, and then it says, okay, give me a new image. Okay, so here's an image that the program did not know, or I should say the model did not know. Right, in pizza, where's my pizza image? So here's this. Is that a hot dog or not a hot dog? So let's run this. So it's below 50%. So most likely it's not a hot dog. So I actually changed the code a little bit. So if it's above 80%, I put, like, it's a high probability it's a hot dog. If it's over 50%, so it's probably a hot dog. And if it's below 50%, then most likely it's not a hot dog. So the pizza was 45%. So most likely it's not a hot dog. So let's images. How about so here's a dinner that I made recently, very proud of. Lobster potato. So let's
Make my mouth water here, Frank.
Oops, don't want that. Don't want that. Hello, lobster. TOTATL. So let's try that. So let's run this program with a different image. And that one, okay, well, that one was, well, no question. It's not a hot dog, right? And if you just, so it looked at that, it said like, nope, there are no hot dogs. So it actually, it looked at this and it said, no, that's not a hot dog. This, okay, let's do that one. It's a underscore dog, okay. Let's try this.
I hate to ask it about if you give it an image of a po' boy or something, it would think it's a hot dog.
It could be. So put that hot dog image, and that's this. Oops, that's not one. This guy. It said this is a high probability as a hot dog. 98%, sure. So have I put this picture in here? And some people have called me a hot dog. So let's put that in there. Let's see what it says for me. Okay. Okay, so luckily it's a friendly program. It says that I'm not a hot dog, so I could tell my friends I'm not a hot dog. So both of these programs, or actually both, we have two repos that for hot dog, not hot dog, and also that little mushroom Chihuahua program are both in GitHub. Let's see if I have the links someplace here. Well, actually, to get started, there's this this link that you can follow. Just there's a getting started guide that we wrote to help you get started. There's all kinds of other things that we wrote. There's a mailing list for VisRec. So I think I'll leave it there. I would just ask to please try it out and then let me know. Let both Zora and I know what you like and what you don't like. How can we change it in the future? But it's Java friendly. It's not a Java wrapper around C libraries. You don't have to understand C. You don't have to understand anything low level. It's Java friendly. It feels like Java, and it is Java. So thank you very much for letting me speak about our JSR. We're very proud of it. So any questions?
Right. So that API, the reference implementation, it's entirely Java.
Yes. Nice.
It has a performance compared to, say, other Python libraries.
We've had a couple of users that have actually written blog posts saying that so remember it's an API, Victor. So it relies on the engine underneath. So we have a user that's using GraalVM, and he said like it's really fast. But that's an engine below the engine, right? So he's using DeepNets, which is an engine for the API, and then there's like GraalVM underneath that.
Very impressive.
And we have people that are using it. We have two users that are using it for Android, and the size of the model is tiny. So some of the models, some of the other systems for mobile devices, the models are huge. And so our models are very, very small.
That's really handy, actually. You mentioned that one of my colleagues here at Improving Houston presented on how to use Kotlin for ML, and I posted that talk on YouTube, and someone had asked if he could apply this to his Android application. So it's great to hear that JSR381 could also be used here as well on Android applications. So that's to talk to the model, I'm assuming, rather than to generate the models.
So both. If you want to create the model, yeah, for both.
Okay. Wow, that's impressive. You just have to have a powerful enough Android device. Of course, I guess now, come think of it though, with Android, a lot of Android devices packaged with GPUs now. I mean, it's why not? You know, I mean, you
Yeah,
certainly
sure.
leverage those GPUs. Of course, battery life might take a hit, but definitely a possibility.
Yeah, I mean, certainly. I mean, so Zoran is the author of Deep Nets, and since he knew Deep Nets, I said, let's use Deep Nets since you know that intimately. And so we used the community edition, the open source version of Deep Nets, and there is, of course, there's a commercial version of Deep Nets that uses like heavy duty multi-threading. There's GPU support, all that stuff for commercial. But I mean, for developers, that's all. If you want to use it to test things out, that's all free as you would expect.
Okay, nice. Very good.
One more question, Frank.
Hi.
What's so
I do have a question. Can
Sure.
So is there a open source, perhaps, maybe it's a lot to ask, but like an open source repository where the models are pre-built for different types of things? Or is it always the case that we would need, like, for any prediction we want to do for an image, we would need like 10,000 images to fetch for ourselves somewhere to be able to create a model for it?
That's a good question. We have thought about that. I mean, certainly the industry as a whole has thought about that of having a collection of models. I mean, look at TensorFlow and Android, right? So there are models that you can download, that existing ones, like there's several hundred that Google has that you could download to an Android device. But they're good up to a point. They're good probably for learning about ML, but to put it in production is then when you have to actually do real work, right? Because I taught Android and I've taught Kotlin and using ML on an Android device and using the built-in tiny models, which will tell you that yes, this is a dog, but that's what it'll tell you. I mean, you want to know like the species of dog and this and that. So there's a lot more work you have to do. But there is talk about having these models, but you have to have standardized models, right? You can't just have TensorFlow model and then this other vendor's model. There has to be standardization. So that's what the industry is going through now. There are initiatives to standardize models, and I think Onyx is one. Is it ONNX that Microsoft has been championing? They're trying to do that, but it's still early, in my opinion.
All right, thank you.
I know that I'd taken a machine learning course kind of through my employer, and the president of the Eastern office actually taught it. And one of the things that he mentioned was that a lot of previously openly available data sets are basically disappearing because they're put out by enterprises, and they realize that these are valuable data sets that are useful for training. They say, well, you know what, we're gonna take those back. So it's kind of scary almost.
It's scary, but I think Tim O'Reilly said, like, open source. Of course, open source ruled everything, right? It's code. Code has to be open source, but with ML, it's not the code, it's the data. Data is food for ML, right? So data sets are going to be like the new open source going forward. It's not just the code, it's the data. The data is food for ML, so it's important. It has to be clean data, right? And the models, because you can see how a hacker can poison data and poison a model. It's not going to be poisoning the code; they're going to poison the data, right? So there's always going to be people with the black hats that doing evil things. So it's just the way it goes. So we just have to be very careful about using what models in production. Victor, you got a question?
Yeah, I did. I was wondering, like, what's on the horizon? Are we going to try to make more APIs for additional? Because it seems like it covered really a lot. I mean, you have a model, you have predictions, you have labels.
Well, so we have, to JSR, we have what we set out to do and have a standard API. We want to add, and we see what happens with Loom, and using multi-threading. Will that help? Well, maybe it won't help. Maybe it will help. We're not sure whether it'll help or not. So that's something that we're planning on doing. Of course, hardware support. We want to look at some of the NVIDIA hardware, like NVIDIA's API, the CUDA APIs, instead of writing directly to the hardware, writing to a standardized machine API. So we're looking at using that to speed up things. Performance is a big thing with training. So we're trying to see what we can do with in the cloud too, as a service.
I know they had something going on where they were integrating with the Graal VM with one of their projects, but then it kind of fell by the wayside from what it looked like.
Mm-hmm. Well, I guess we want to see also what Panama or Project Panama has to offer too, right?
Mm-hmm. Oh yeah, absolutely.
It's been taking quite a long time for Project by Panama to kind of see the light of day. Let's see what happens with that. I mean, the future. I mean, Java. When I talked to Brian Getz at QCon a while ago, he said obviously machine.
Oh, I think we lost Frank a little bit here. Oh dear.
How are those things saved and stored in certain types of hardware?
Sorry, Frank, we lost you just after you started talking about your conversation with Brian Getz and QCon.
Oh, sorry. Yes. So we were talking about Brian and I were talking about the future of Java related to machine learning, and that is a long tail, right? There's like 10 to 20-year tail. There's all kinds of stuff in ML, and he said that Java, he's thinking about having a class called tensors in the language would support AI hardware, which would make it easier to implement AI applications.
Oh, that'd be nice.
But he said that's we're talking a little about in the future. But he said that's everything is ML, right? So ML affects everything. We're looking at programs like visual recognition. It affects like in India, in India, call centers supply much of the GDP, right? It's for the country.
Oh wow!
But with machine learning, do you need humans to do call centers? Maybe not. Maybe you need hardly any. What happens to India's GDP when you rely on that?
Yeah, I see what you mean by global
right?
implications. Yeah.
Right, and there's all. It's just like when I first learned about Java, like I said before, when I first learned Java, it just wasn't a language. I just saw wow, it's like all this other stuff. It's not just a language. It's like all this other stuff. There's all these different tangents to go off on, and all these different threads to follow. The same thing with machine learning. That's what struck me, is that not only is it just a set of APIs, but it affects how we access data. I mean, there's people looking at ML and redesigning operating systems now, and just simply accessing data. It's no longer like database type of algorithms. It's machine learning algorithm accessing data. And how does it do this at the low level? How does it affect operating systems? There's conferences on AI hardware. How does that all fit into this, right? And if once we go past the hardware level, what's next? It's the software. So new languages will be invented, right? And new types of ways of interoperate or integrating with the hardware. So I mean, if I was a young developer right now, this is the field to be in, right?
Yeah, and that also mean going the opposite direction, beyond just the operating system and from software to hardware down to the data center level. How do you get all these computers to talk to one another? I mean, we're seeing an article in InfoQ about how Microsoft was able to take and basically have a large number of computers cooperate in a shared memory space. Basically, I was blown away by that capability. I was like, wow, holy cow! You basically have this shared network of memory that you can use to train and train a data set, basically.
Mm-hmm. Yeah, it's a fascinating field. I mean, it's whenever I'm reading about the AI ML hardware, that's just so cool. All the stuff that's being created, but then that'll need software, right? So the next few years there's like a hardware renaissance with different types of hardware, because we found out that cores don't scale because of heat, right? So So we have to say, what do we do? So now there's AI hardware, but now we have this complex architecture. It's not just cores that are just symmetric. Its architecture is diverse. How do you create an efficient system using a diverse architecture? How does it affect, right? How does it affect operating systems? What new languages do we need? Maybe new languages or new DSLs will help us with machine learning, right? So this is very, very exciting. And of course, then there's the ethical things and the privacy and that affects humans, right? And there's so many things that the ML affects. That's why it's not just one thing of many. It's like a wrapper around everything. And since everything we do has a notion of patterns, this is like that one evening when I was kind of thinking about this. If everything in the universe is based on patterns, and machine learning is all about patterns, and machines can do stuff with patterns, it's sort of scary. It's sort of scary.
Yeah, it's a very fascinating area. Certainly, try to see if we can help one another to improve our lives in many, many ways.
Yeah. But thanks for having me, Jim.
I know. Thanks. It's been a delight, Frank. Thank you so very much. This has been really neat, and just to see that we have machine learning as a first-class citizen in Java, I'm really excited. There have been other tools that I've tried here and there, just as part of classes, stuff like that, and they do okay. But to some extent, they require a lot of learning, or they require some use of applications, which is not bad, but it's not straight coding. Whereas this provides that capability, which is nice.
Yep. I mean, you'll find yourself at home with the API.
Cool. That's I'm really excited. This is great. Any other questions, Utran or Joel?
Yeah, nothing much. Yeah, thanks for the great presentation. Yeah,
good.
You're welcome.
really good. Impressed.
You're welcome.
Thank you very much.
Yeah, thank you very much.
You're welcome.
Okay, cool. Well, join us in about a month. Modern.io is the website of the next presenters that we have on July 27th. If you want to mark your calendars, I'll get something on Eventbrite pretty soon and start getting the word out about it. And again, thank you to our sponsors, Improving, and our door prize sponsors, JetBrains and Hello Tomorrow and Headway Software, and Big Hat Supermoney and Agile Learner and Webucator. Thank you all again so very much, and thank you so much, Frank, for taking time out of your evening and for presenting this. And
my pleasure.
I will go ahead and get this on YouTube within probably the next 15 minutes or so, and get the link out. Cool. All right. Thanks so much. Have a great one. Thank you. Bye-bye.
Bye.